This lesson is about expected value. So when you're taking into account the probability of things, what is the expected value to you? Now that we've explored ways to calculate probabilities, let's look at how we can use probabilities to predict the average outcome when an event takes on numerical values. Expected value is just that, what you would anticipate getting if you took the average of all the sample events. Here's how you find expected value. And I know this formula looks complicated, but once we get to an example, you'll see that the formula itself is not that complicated. It's the value for the first event times the probability for the first event, plus the value of the second event times the probability of the second event, plus the value of the third event times the probability of the third event, and so forth. So given this table and the outcomes and their probabilities, you can complete the table to help you calculate the expected value of the event. So what you would do is multiply these, multiply these, multiply these, add them all up, and you get 5.4. The sum of expected values. The expected value of the union of two mutually exclusive events, X and Y, is equal to the sum of the individual expected values. Normally we can write this as the expected value of X and Y is equal to the expected value of X plus the expected value of Y. The campus dining service at State University is preparing for the upcoming year. Based on past years, they've observed the following data on the probability of selling different meal plans. Each plan consists of a set number of meals along with plus dollars, which can be used anywhere on campus but are restricted to food purchases. The university predicts an enrollment of 8,421 students in the coming year. So the first meal plan would be 19 meals per week and $100 plus for the semester. And its price is $1,245, and the probability of students getting this plan is 1 in 10. And you can see there's 5 different plans here. Suppose a random student from the university is chosen. What is the expected value for the amount that they have spent on their meal plan for that year? So, we take the probability times the price for each one. So for the first one, the probability that they get the first plan is 1 in 10, and its price is $12.45. Then we add that to the probability that they get the second plan, 1 in 15, times the price, also $12.45. And then for the third, that was 1 in 30 with a price of $12.45. For the fourth, 1 in 10 get this plan for a price of $815, and 1 in 12 get the last plan for a price of $870. So we go through and multiply these. 1/10 times $12.45 is $124.50. 1/15 times $12.45 is $83. 1/30, forgot my zero, times $12.45 is $41 50. 1/10 times 815 is 8150, and 1/12 times 870 is 7250. Add all those up, $403. That's the expected value for the amount that they've spent on their meal plan for the year. Suppose for each meal plan sold, the university makes $510 from Plan 1, $550 from Plan 2, and so forth as listed here. What is the expected profit per student in the upcoming year? Okay, so we do the same thing, only this time it's with those profits. So 1/10 times 510 plus 1/15 times 550 plus 1/30 times 600 plus 1/10 times 220 and 1/12 times 270. And we get an expected value of $152.27. C says, what overall profit can dining services expect from the student meal plans in the upcoming years? Well, if we take our $152.27 and multiply that by the 8,421 students, then the meal plans will make this university $1,282,265.67. In American Roulette, the wheel contains the numbers 1 through 36, alternating between black and red. There are 2 green spaces, numbered 0 and 00. Calculate the probability of the roulette ball landing on a red pocket, or black for that matter, since there's the same number of red and black pockets. So, the probability of a red. And we are assuming that the probability is equally likely. So there's 18 red pockets out of 38 pockets total. So that's 9 and 19. It says, calculate the probability of the ball not landing on a red pocket. That's 1 minus the probability of a red, which was 9 and 19. It's 10 and 19. C says, a player bets $1 on red to play the game. Calculate his expected winnings. So there's a 9 and 19 chance that he'll get $1. And there's a 10 and 19 chance that he will lose $1. So we're putting -1 because he's losing. So we just take 9/19 minus 10/19 and get his expected value is to lose 5 cents. Of course, that's not going to happen. He's either going to win $1 or lose $1. But if the idea here is if you were to take thousands of players that we're going to bet $1, or if he were to bet thousands of times $1 on a red, then his expected value at the end of thousands and thousands of bets would be that he would lose a nickel. And that's the end of that section. I have just one example for our expected value section. It says, suppose that you and a friend are playing cards and decide to make a bet. If you draw 3 diamonds in succession from a standard deck of 52 cards with replacement, you win $50. Otherwise, you pay your friend $10. What is the expected value of your bet? Okay. So the way we'd figure our expected value here is what you would win, $50, times the probability that you would win that $50. So the probability of 3 diamonds. And we'd add to that the fact that you lose $10, so we have to put a negative 10, times the probability that you do not get 3 diamonds. Okay, so let's go over to the side and find the probability that we would draw 3 diamonds in a row. So the probability that you draw a diamond, there's 13 diamonds out of 52 cards. And it says that this is with replacement, so the second time would be 13 out of 52, and the third time would be 13 out of 52. If it was without replacement, then it would be 12 and 11. Well, we're multiplying for these 3 chances, and that gives us 2,197 over 140,608, which reduces to 1 over 64. Now, to find the probability that we do not get 3 diamonds, that would be 1 minus the probability that we do get 3 diamonds. So 1 minus 1 over 64. Or 63 over 64. So we can go back to our expected value equation and plug in our probability for 3 diamonds and our probability for not getting 3 diamonds. Why does it keep doing that? And we would end up with negative $9.06. So your expected value is that you would lose $9.06. Now, do keep in mind that this isn't saying that you would lose $9.06. This is just the expected value. There's really only 2 chances. Either you get 50 or you lose 10. What this tells us is that there's a good chance of you losing, so you probably should not play this game. And that's the only example we have for Section 5.